Now let me introduce this new cartoon custom rig system. You might only need one hand, or even just a few fingers. With this, you can build a custom rig and freely add or remove parts as needed. It also supports some stretching effects. For this model, try to keep it centered on the world axis and make sure it's facing the negative y-axis. Open this menu. Click on Advanced Custom Body Rig Edit. The top section here is a preview area for templates. Since there's no template yet, you can ignore it for now. First, set the rig name. For example, call it Test. Then click Create. A large circle will be created. The text in front is the name you set. For the root, when it's not selected, these buttons will light up. So first, select the large circle. This enters edit mode. Click it, and you can edit its position. But this is not for editing the large circle itself. If you click Delete, it will delete the entire large circle. Then you can create it again. Click this pivot option. This represents the center of the whole object. Here you can scale its size. A rough scale is enough. This area will turn purple, which means this is the back side of the entire module. When you select the large circle, the pivot option lights up. This indicates that the large circle can only create the center module, but when you select the center module, you can create a spine, or arms and legs. If you have a tail, hair, or a skirt, you can use the chain option. For example, to create a spine, just click Spine. Its size is based on the scale value. You can also scale it, and it won't affect the other parts. This component here is the base. You can scale it down a bit. You can move its position. Switch to edit mode. The control axis will not move. For example, rotating it like this has nothing to do with skin weights. It's essentially just like a joint. Other components have different positions. If you don't operate in edit mode, you'll affect other parts. If you only want to adjust the part itself, do it in edit mode. If you want to scale, you need to turn off edit mode. When you click the chest, the names of each part appear here. Clicking this one, this corresponds to spine 1. You can rename it. Of course, Max allows duplicate names. So when renaming, be careful, duplicate names may cause errors. When you click the chest, the head option lights up. If a button is gray, it means that feature is unavailable. When selecting the spine, you can change it to multiple segments. For example, moving this upward, it becomes 3 segments. Some animals need multiple spine joints, so you can keep adding segments upward. Currently, up to 8 bone segments are supported. Here, I'll just use a single segment. There is an option called Chest Control in Center. This means the generated controller will be placed at the center of this module. If you don't enable this, it will be placed at the position of the lower controller. This option is disabled by default. After creating the chest, click on Head, and the Head module will be created. You can scale this base. It will not affect its child modules. Move this slightly backward and align it with the neck position. Head weights usually need to be adjusted manually later. Only basic auto weighting is provided here. The head is essentially another chest module. You can even create an arm from it. You can create it however you like. If you want to delete it, try to delete it from this panel. For example, if you delete the chest here, the head will also be deleted. All child modules will be removed, but the parent module will remain. Create an arm. Here you have a clavicle option. You can choose to enable or disable it. It is enabled by default. Try to rotate in local mode, since the model has many vertices. Place it as close to the joint as possible. Usually start from top to bottom, beginning with the parent. You can rotate it slightly. This is the pole vector. The pole vector rotates along with the corresponding joint. For this arm, you can configure it. For example, the upper arm. If you select one, it will be split into 3 segments. The forearm can also be set. You'll see it becomes 3 bones. Select the palm. For example, use 1 finger. It will become 3 segments. Now adjust the palm. Click on the second finger and align it with the joint. You can also scale it if needed. Try to do everything in local mode. Snap it to the joint position. The size of this box does not matter. The setup for this hand is complete. The other hand can be mirrored. First, select one arm module. Click Copy. It will record the settings. Paste. The mirror option will light up. Mirror it to the right side of the character. For example, if you change it to one segment, click Copy, then click Paste. The right side will also become one segment. This is how copy and paste works for every module. Copy and paste are available. Here you can adjust the bone count. Select the palm. Each finger is a separate bone chain. For example, it's currently 3 segments. If you change it here, it becomes 2 segments. Next, create the leg. For example, select this pivot. Click Next. The leg will be created. Legs do not have clavicles, but you can add one. For example, a horse's front leg needs this bone. Rotate the leg normally. Try not to rotate the lower controllers. Move the foot to this position. Press V and set it to 60 degrees. This is the controller. This point represents the heel. The one behind it is the heel controller. It will be created at the corresponding position. Select this foot again and click Copy. Then create another one. Click Paste Mirror. It will be positioned based on the current settings. This controller can also be set to 3 twist bones. The setup is the same as the arm. There is also the tail. You can select the middle and click Chain. Then drag it out. For example, start by creating 2 segments. Then change it to 3. This way the spacing is more even. This can also be copied and pasted. For example, place it here, then click Copy. Click Paste Mirror. The mirrored position is based on the parent's transform, using its XY axis across the center line. There are 2 creation methods. One is spring, and one is FK. Spring mode means it can play automatically. After creation, there will be several attributes. It behaves like a spring with secondary motion. FK is a standard tail controller. You can create both. When you switch between them, the attributes here will change. Choose based on your needs. Now a full modular character has been created. During creation, you will see a prompt. It asks whether you want to continue. Because this operation is irreversible, it's best to save a template first. Once you click Yes, you cannot return to the current state. This template becomes very important. First, assign a save location for the template. For example, save it here. After setting it up, when you hover your mouse over it, the template path will be displayed. click the large circle. Then click Save. It will open the template path you just set. Click Save. After a moment, it will be saved. Sometimes the display may break because the panel is compressed. Let me demonstrate the compressed state. You can see it has been compressed. So how do you use this template? For example, if you accidentally click Delete and remove everything, you can use this template. For example, if you create an arm, it will first delete everything, then recreate it based on the template. For example, click Load here. It will ask whether you want to use template A. Click Yes. It will delete the old template first. After deletion, it will recreate everything. Based on this template, you can see that the template has been recreated. Right-click this button, and it will open the template directory. You can see the template files, including its preview image and data files. All these templates are named ACB. Now you can create the controllers. It will generate the controllers. If you want to keep editing, just create a new controller setup and load your previously saved template. This is mainly for easier iteration and modification. After creation, you can take a look. All these colors are removed. This makes it easier to distinguish whether twist bones exist. If I click these boxes, they all turn gray, which means they are disabled. Now let's talk about skin weighting. There are two methods. One is voxel, and the other is heat map. For example, if your topology isn't very clean, you can choose voxel. You must select the big circle first, otherwise this won't be enabled. If your topology is more even, you can use heat map. The properties below. INF means influence count. Games usually use 4 influences. Film and cinematic rigs use more. The default is 4. Weakened controls fall off. It affects how the weights decay. It depends on the result you want. With heat map, the denser the mesh, the slower the calculation. Voxel is relatively faster. First, select the big circle, then select the mesh. If you have multiple meshes, such as eyes, nose, tongue, and so on, you can select them all. But always select the big circle first. Select the meshes and click Skin. Click Skin. You can check the resulting weights here. Here you'll see groups. For example, if you created something named test, it will generate a group. One is a node group, and one is a controller group. These controllers represent all the bones. This is the full skeleton. You can see that the weights are applied correctly. Each controller has a custom attribute. Click it, and it will reset to 0. Here are some IC and FK settings for the arms. This is currently a simple fast 2-arm rig. For the tail, this side is the spring chain, so it has additional attributes. This side is the FK chain, which has fewer attributes. These two behave differently, including their controllers. One more thing to add about this. The heat map option in auto skinning calculates weights based on polygon faces. automatically. If your mesh has more polygons, the calculation time will be longer. For meshes with millions of polygons, it can take a very long time. So clicking this may cause heavy lag. This mesh here has just over 10,000 faces, so it finishes very quickly. When using auto skinning, if you only need a fast result, use voxel. If you want higher quality weights, use heat map. But if your mesh is extremely dense, for fast initial weights, voxel is the better choice. With very high polygon counts, heat map will take much longer. That's it. Thanks for watching.